I hope you are good. Today we are going to discuss about the solutions of our trigonometric identities for AS level. Before we start the solution, a few important things you need to recall in your mind, that are angles in different quadrants. Okay, here we have 4 quadrants. Like here you can see cos of theta, that's representing the x-axis, and here negative cos theta, that represents the negative x-axis. Here we have vertically sine theta, that is representing positive y-axis, and negative sine theta, that representing negative y-axis. So this we call the first quadrant, as you are well aware about it. This is second one, this is third one, and this is fourth one. First of all, you should know, in the first quadrant we have cos positive, sine positive, and you know tangent is the ratio of sine to cos, so positive or positive, it becomes positive. And in the other sense, we can say add sugar to coffee. Yeah. Okay, so here this was the first quadrant. Here goes the second one. In the second quadrant, you can see the cos is negative here, and sine remains positive, and tangent is the ratio of sine to cos, positive or negative become negative. So this is the second quadrant. And in third quadrant, cos is negative, sine as well negative, because you know sine is negative here, cos is negative, so tan will be negative or negative become positive. While in the fourth quadrant, you can see the cos is positive, but sine is negative here, so and tan will be negative. This is the signs of the trigonometric ratios in different quadrants. Now we will talk about the angles in different quadrants. If you talk, if you are going for the anti-clockwise, it means the all angles will be positive. Like this, I'm going, the arrows will indicate in which direction you are. If your angle of any trigonometry is lying in the first quadrant, then it will remain theta. But if it's in second quadrant, we know the total angles, this one is what? Angle on a straight line is always 180 degree or pi radian. So this is 180 degree, this whole one. So it is, as it is less than 180, so we can say it will be 180 minus theta, that will be the angle formed in the, that is angle formed in the which quadrant? Second quadrant. Okay, fine. And similarly, if we proceed for the third quadrant, third is less than 270 and but more than 180, because for third you have to come from here, you can see till here, right? So I can say it is more than 180. 180 plus angle theta will give you the angles in the, if it is theta degree, it will be this degree, it will be this degree as well, right? So finally, if the angle or trigonometric ratio is lying in the fourth quadrant, then it will be less than 360 or more than 270. We can say, here I'm going to write here 360 minus theta degree. This is the angle formation which we have to follow for the whole trigonometry solution. Right, I hope it is clear. Now we will proceed for a few questions to help us to know the location of the angle. Okay guys, this we have done for the angle which is going to be positive, and now we will solve with a negative. We can solve it for the identities, like solve. Here goes the question. We have to solve this question. uh, 2 sine x tan x plus 3 is equal to 0, and you can see the angle required result can fall between 0 degree to 360 degree positively. Okay, uh, so let's see. We have to solve it. 2 sine x, and the tan x will be sine x to cos of x equal to minus 3. We have to because whenever we need to solve, we need the trigonometric identities, we need to get one identities with all respect in the equation to solve it. So that's why first we will break tan x into ratio sine over cos. So here we get 2 sine x into sine x means sine square x over cos of x equal to minus 3. To the cross multiplication, we get 2 sine square x equal to minus 3 cos of x. Now still we have two trigonometries, that is cos x and sine square x. We know sine square can be broken down into cos square, so I can write 2, and this will be 1 minus cos square x equal to minus 3 cos of x. So 2 minus 2 cos square x is equal to minus 3 cos of x. Shift all to the right. 2 cos square x minus 3 cos of x minus 2. So finally we get a quadratic equation in term of the variable, that is cos x. 2 cos square of x minus 3 cos of x minus 2 equal to 0. Now you can apply the quadratic formula or factors, any method what you know, to solve a quadratic equation with the variable cos x. Okay guys, here now you can apply the quadratic formula or factors, midterm break rule, whatever is easy for you. So here for your sake I'm going to make the factors. Minus 4 factors is 2 cos square x minus 4 cos of x plus 1 cos of x minus 2 equal to 0. I made the midterm break rule. So what is common from here? 2 cos of x, we get cos square x minus 2 plus here what is common here? 1 cos x minus 2, sorry, here it is cos x, right, is equal to 0. Now this comes out as a common, cos x minus 2 equal to times 2 cos of x plus 1 equal to 0. Now when we will take cos x minus 2 equal to 0, or for 2 cos of x plus 1 equal to 0. Now here comes cos of x equal to 2. X will be cos inverse of 2, as we know that the range of cos is lying between minus 1 to 1, yeah, including, so it is more than that, so it's not possible. Not possible. But solution, we can write solution is not possible. Solution is not possible. So let's proceed to the other part. Here we have 2 cos of x is equal to minus 1. Cos of x will be minus 1 by 2. So here you can see cos is negative. Here you can see the cos x comes to be negative, less than 0. So if you can recall that it will fall in which quadrant, cos can be negative, is negative in second quadrant here, and in the third quadrant, and rest it is positive. So your answer will fall in second and third quadrant, right? Let's proceed to the solution, further solution. Yeah, so I will see what comes angle here. X will be cos inverse of 1 by 2 here you can write is second and third quadrant, because we checked our cos is negative in second and third quadrant. So shift cos 1 by, I get I got x is equal to 60 degree. But this is not my final answer, because my cos, which is negative, is lying in second and third quadrant. So final solution is, I know in the second quadrant x will be 180 degree minus x degree, so it will be 180 minus 60 degree. I will get 120 degree. This is one of my answer. And in the third quadrant, this is for the second quad, in the third quad x is 180 degree plus x degree, that goes to be 180 plus 60, that is 240 degree. That is my final results for the said question. I hope you got it. Guys, now we have a question to solve. 2 tan square x theta times sine square theta is equal to 1. Angles range is lying between 0 and 360. So you can see we have two different type of trigonometric identities. We need to shift it in one first. So as we know, tan theta is the ratio of sine theta over cos theta. So it will be broken down like sine square theta over cos square theta times sine square theta equal to 1, right? We have 2 sine square theta, it can be 4 theta, right? We will get here 2 sine into sine 4 theta over cos square theta is equal to 1. To the cross multiplication, 2 sine 4 theta is equal to cos square theta, and we know that cos square theta equal to 1 minus sine square theta. Again, I'm telling you, our first option or target is to bring a single trigonometric function so that we can factorize it or solve it. With different, we can't. So this is will be broken down in this will be 1 minus sine square theta, and here we have 2 sine 4 theta. Bring every term here, we get 2 sine 4 theta plus sine square theta minus 1 equal to 0. Now you can see we have one function in term of sine theta. It has maximum power 4. So to make it quadratic, we can say let x equal to sine square theta. So make it convertible to quadratic. So x square will be sine 2 square means square, that's equal to 4 theta. So we finally get 2x square plus x minus 1 equal to 0. Now here, in order to get the solution in term of x, you can apply the midterm break rule if you know and you're good in that, fine. Otherwise, apply the quadratic formula. Here you don't have any restriction for any method. Okay, suppose this is 1. So what to do? I'm going to apply the midterm x square plus 2x minus 1x minus 1 equal to 0. So 2x is common, x plus 1 minus 1, again x plus 1 equal to 0. Take this common, we get x plus 1 and 2x minus 1 equal to 0. Okay guys, further we get x equal to minus 1 and 2x equal to 1 mean x equal to 1 by 2. Now what to do? We need to substitute the values of x in equation 1. So we can write from 1 we have a sine square of x equal to minus 1. So sine x taking square root on both sides, you know negative square root is not possible because that is a part of complex number, so you will ignore, so ignore. But for the other side, once you take sine square x is equal to 1 by 2, sine x will be 1 over plus minus 1 over root 2. Here you know we have two results. Case 1, we can say case 1 when sine x is 1 over root 2, that is greater than 0, positive. So you need to recall the concept where sine is positive. It is positive in first and second quadrant, right? I will show you this thing here. Oh, wait a minute. If you can recall, yeah, here you can see sine is positive in the first and what, second quadrant, you can see from the table. So we will proceed back to question here. Yeah, yes, okay, we are solving the first case so far when it is positive. So what to do? X will be sine inverse of 1 over root 2. So get the values, use a calculator, and we'll get 45 degree. Okay, this is the angle, but we got 45 degree. Now what to do? In the first quadrant it was fine, and the other solution x will be 180 minus 45 degree, that is 135 degree. There's two answers for the case 1. Similarly, we will proceed when case 2. When sine x is negative 1 over root 2 and this is negative, so sine is negative in the third and fourth quadrant, right? So again back to the table, and you can recall it. Here we will get x again 45 degree, but as in the third quadrant, in I can say the third quad, your x will be 180 plus 45, we got 225 degree. You can use the calculator. This is the another answer. Similarly in fourth quadrant, x will be 360 minus 45 degree, so 315 degree is the final answer. So finally we can say that the four solutions, the required solutions of the set question are thus required solutions are: number 1, it was 45 degree, then 135 degree, 225 degree, and 315 degree. I hope you got it. Okay guys, now we have to solve another question, that is 1 minus cos theta 1 plus sin theta is equal to 2 by 5, and your angle range is lying between 0 and 360 degree. So first what to do, as a single trigonometric ratios we have given, we need to make a linear equation or quadratic equation, like by cross multiplying either side. We get 5 minus 5 cos of theta is equal to 2 plus 2 cos of theta. Bring all cos one side and constant on other side. we get 5 cos of theta plus 2 cos of theta. 3 comes to be 7 cos theta. So it means divided by 7 on either side, we get 3 by 7 is equal to what? Cos theta. And here it is greater than 0. So cos is lying positive in the first and in the fourth quadrant. You will see here, like I'm going to draw here, cos is positive here and cos is positive here in the fourth. Cos is negative here, cos is negative here in the other two quadrants. So 1 and 4th are valid for solution, but third and second and third are not valid for solution, right? So we have to answer accordingly. So let's solve it with the help of calculator. You will get, so with the help of calculator, once you take the cos inverse of 3 by 7, angle will be 64.6, one decimal place is fine enough, degree. So required solution falls as it in first and second fourth quadrant. So first one answer is here, right? You write in fourth quad. What is the theta will be 360 minus theta is 64.6 degree minus. So with the help of calculator, you will get a theta will be 295.4 degree. So these are the two required results. I hope you got it. Okay, fine, students. Now this time we have to prove, we have to solve that 2 cos square theta is equal to tan square theta within the given range in radian. 0 angle is lying between 0 and pi radian, right? And giving your answer or solution in term of pi. So let's start. We have 2 cos square theta is equal to tan square theta. Here two different identities can be split up to make it one identity. Tan square is equal to sine square over cos square theta. Do the cross multiplication, we get 2 cos square becomes 4 theta is equal to sine square theta. Now we can divide this sine square in term of cos square, that is 1 minus cos square theta. Okay, bring every term on the left hand side. From right we have cos square theta plus cos square theta minus 1 equal to 0. Now you have this term with the power 4. So again, as we did before, let x or y, any dummy variable you can suppose, is equal to cos square of theta. So x square will be cos 4 theta. Now we will have a quadratic equation in term of variable x, and suppose this is 1, because finally after evaluating the value of x we have to resubstitute to get theta. Plus cos of theta minus 1 equal to 0. It's up to you, either you can apply the quadratic formula or midterm break rule. So I'm going to apply the midterm, either x, 2x minus 1x minus 1 equal to 0. So 2x, x plus 1 minus 1, x plus 1 equal to 0. So finally I got the factors in term of this one, right? Okay, so values of x will be, x is either minus 1 or it will be, x comes to be from here 1 by 2. I hope you got it. Now we need to substitute the values of x one by one in equation 1 to solve for theta. Yes, now substituting the values here in above, yeah, here in 1, that was cos square of theta was equal to x. Substitute values of x in this, we get when cos square theta is equal to minus 1. You know that when you take the square root of negative, it's supposed to be complex, so ignore it. So here cos square theta is equal to 1 by 2, so taking the square root we get plus minus 1 over root 2, right? So what to do next? You are well aware we have two cases for this one. We have two cases for cos theta. One, it will be positive 1 over root 2. Say we can say case 1, when cos theta is equal to 1 plus 1 over root 2, right? This one. So it will fall in first and in fourth quadrant. So using calculator, cos inverse of 1 over root 2 will give you 45 degree. So this is in first quadrant. In first quad, theta will be 45 degree. This is your one solution. In fourth quad, in quadrant, theta will be 360 minus theta 45, that will be 315 degree. This is your other solution. Now go with the case 2. Case 2, when theta is taken as negative, meaning cos theta is negative 1 over root 2, right? So it is less than 0, so it falls in second and in third quad. Let's see what comes the result. So here theta will be, again we get cos inverse of 1 over root 2, that give you 45 degree again. So here you write in second quad, what comes, theta will be 180. Sorry, we are given the angles, if you can see, in radian here. Yes, domain is 0 to pi, so we will not proceed. So in term of pi, let it be in term of pi. Here it will be, you need to change the mode of calculator, please. Here find, let me write this one. This will be in term of pi, in pi radian. Okay guys, in second quad, in pi radian, you need to write this in not 45, it will be pi by 4, because written in question. So one answer is pi by 4. And fourth quadrant, that is beyond the given domain, so you can say fourth quadrant, you can say lies beyond the given domain, that was 0 is less than theta was less than pi, right? So ignore only one answer. And similarly proceed for the second quadrant. Again here it will be pi by 4, so pi minus pi by 4, second quadrant will be 3 pi by 4. Another answer is 3 pi by 4, right? We did this because the given domain is in term of pi, so we need to change the calculator mode from degree to radian first, and then answer accordingly. Fine. And finally you can check in the third quadrant. In third quadrant, as it lies, means angle lies again beyond the given domain, that was 0 till theta is pi, so ignore. Finally we get the final solutions. Our required solutions are only two. Thus required solutions are one is pi by 4 and other is 3 pi by 4. I hope it's clear to everyone.